This is part 18 of 8086 instruction set, and we will be seeing some load and store string instructions. Suppose that we need to load a particular byte in a string onto a register, maybe accumulator. So for that we can use a LODSB, that is load string byte. Okay, so the setup to execute this is the string byte that we wish to take out onto a register needs to be pointed to by DS as a combination, and we have to issue LODSB instruction so that that particular byte will be taken and will be placed in AL. And note that we might be interested in multiple bytes of the string. So after LODSB is executed, that is a copy happens, automatically SI will be updated so that if we are interested in the next immediate byte, that byte can also be taken out through another execution of LODSB. So this is the working of LODSB. So whatever byte is pointed to by DSSI combination, as we saw earlier here, right, that will be copied onto AL, and as there is the index register getting incremented, right, we have also an option to decrement the index register if we need. So as usual for the earlier string operations that we saw, direction flag will decide whether in which direction the SI should be incremented. If direction flag is unset, SI will be incremented in the positive direction of addresses, while if DF is set, then SI will be decremented. Then similar to LODSB, we have LODSW. That means if we need to take out a word from a particular string, right, LODSW can be used. So the setup is same, just like LODSB. So DSSA combination will be pointing to the start of the word which we are interested in the string. So here if we need to copy out BE onto AL or AX, right? So what happens is DSSA combination should point to B, starting B, right? And LODSW will be issued and it will be copied to AL or X. So this is the working of LODSW. So DSSA combination is the pointer to the beginning of the word within the string we are interested in. So it will be first copied to X. Then based on the direction flag setting, SI will be made to point to the next word, that is ED, or to the previous word, as the case may be, like we saw for other string instructions. Now suppose that we need to make a string in primary memory. Okay, that is based on our program's output. Dynamically we need to construct a string in primary memory. So what can we do? For that we have store instructions. Okay, so store instructions, actually they will take out the contents within register onto primary memory so that we can construct a string. So note that string is sequence of contiguous bytes, right? So whatever we have in the registers, we have an option to keep them in contiguous locations in the primary memory. So that is a facility offered by the store instructions. So as we saw for load instructions, store also gives us the varieties to move at either at byte level or at word level. So let's see the byte level first. So suppose that I need to construct a string out of some output that I have across AL, across time. Okay, so for that I need to set up ESDI to point to the location from where I need to construct the string. Okay, suppose that I need to construct my string from this particular location in this segment. So ESDI will be made to point to that STOSB. So what happens is whatever content or byte is there in AL, it will be copied to this location and automatically DI will be incremented, okay, if direction flag is unset. So that if I have another dynamic input coming over AL and if I issue STOSB again, right, in the next adjacent byte, that will be placed. So like this way I can construct a continuous sequence of bytes in primary memory as a string. So this is how we can dynamically construct a string using store string at byte level. Okay, so let's see the execution of STOSB. So as I told earlier, whatever content is in AL will be pasted or copied or stored onto the byte pointed to by ESDI combination, and if direction flag is unset, DI will be incremented to the next higher address range, otherwise it will be decremented. Okay, so DI's direction is controlled by the direction flag. Now the other flavor we have is we can construct a string in primary memory from a word register or from 16-bit registers directly, the current 16-bit registers directly. So only thing is we need to put the word in X, and then we have to set ESDI combination to point to the word from where we need to begin the string construction, right? And then we need to issue STOSW. So what happens is this word in AX will be copied to the location pointed to by ESDI combination onto the primary memory, and automatically DI will be incremented by 2 or a word size if dash flag is unset, or it will be decremented by a word size if dash flag is set. Okay, so this is the working of STOSW, that is store string at word level. So whatever content is there in AX, it will move to the word pointed to by ESDI combination, and if the dash flag is unset, as I told earlier, DI will be incremented towards the positive address range, that it will be moving to the next word in primary memory, otherwise it will be decremented or it will be moving to the previous word.